All right, welcome back everybody. We are moving into project 14 of our Arduino starter projects. And this one is tweak the logo, which really means we're gonna be looking at a image. We're gonna expand the window a little bit and then we'll be reading our background color, or we'll be looking at our background color that changes based off the value that we provide through our potentiometer. So looking at the code for this project right off the bat, there's going to be two separate IDEs that we're going to be looking at. The first one is the Arduino IDE that we've seen many times before. And the second one is a Processing IDE, which comes out of processing.org, which if you remember back to the early videos, we downloaded that. Inside the Processing IDE is going to be a little bit more, the code's going to be a little bit more involved. With the Arduino IDE, it's going to be very straightforward. You've seen it so many times now, it's going to be extremely intuitive for you. The Processing IDE is going to be a little bit more challenging because it's new, but we'll walk through everything, so no big deal. Right off the bat, let's go ahead and just complete out our Arduino code that we're going to need. This is what we're going to ultimately load into the Arduino board. And the first thing that we're going to do is we're going to set up our analog pin that we're going to read in from, in this case A0. We've seen this before. This is going to be what reads in from our potentiometer. And then the baud rate 9600. Again, we've seen that several times before when we set up our serial. The only thing about this is, and 9600 being extremely common for a baud rate between serial, when we move into our Processing IDE, we just need to make certain that our baud rate there is also 9600. Again, 9600 being extremely common, probably not going to be an issue, but it is something I just want to point out for everyone to be aware of. So with all that being said, we're going to jump into our setup like we always have before, and we're going to set up our serial lines right off the bat. And the serial begin just sets up the serial, right? And we're passing in the baud rate, which is the data rate of communication. And this, we're not writing to anything, we're not reading from anything, we're just setting up the serial ports to be written to or read from on our Arduino board. Right off the bat, we just want to set everything up. So from there, we jump into our loop. Now, typically what we see for serial inside of our loop is we typically see serial.println, which prints information into our Arduino IDE. In this case, we're not interested in print statements. We're not interested in visually looking at our IDE and seeing something. We are actually interested in reading a value off the serial line. And so we're going to be reading that value in our Processing IDE, which means from our Arduino board, we need to write to the serial line. And what we are going to write to the serial line is the analog value that we read in from our potentiometer, right? And so all we're doing is using the analog read function, which returns an integer between 0 and 1023. And we're going to divide that value by 4, so we get from 0 to 254. And we're going to write that out to the serial line. That's all that we're doing. We're just writing to serial as opposed to doing a print line from serial, because we're not gonna be running the next portion of this project from our Arduino IDE. We're actually going to be running it from our Processing IDE, right? And so doing a serial print line kind of falls on deaf ears, if you will, right? Instead, we need to actually write to the serial. The only other line of code in the Arduino IDE is just delay for 1 millisecond. And that just gives the board that 1 millisecond to get prepared to read in from the next for the next iteration from our potentiometer. But this is it. This is the totality of the code for our Arduino. Nothing new here. We've seen this many times before. The critical thing here is serial.write as opposed to serial.println. And again, that's because we actually want to read values from the serial line so we can use them, so we can use that value in other aspects of our program that we're going to be looking at here in a minute, rather than just reading print lines, right? So with that being said, that's the complete code base for our Arduino board. And this one, you upload this to your Arduino board, and then you shut down the Arduino IDE, and that's when we move into our Processing IDE next. So now in our Processing IDE, you can see that we have two functions right off the bat. We have setup and we have draw. It's just like setup and loop that we have in our Arduino IDE, but within the Processing IDE, we have setup and draw. Now, also keep in mind that this IDE uses a Java the Java programming language, as opposed to more or less C programming language that the Arduino IDE uses. So there's going to be a couple of nuanced differences because of that. And the first one is, for Java, we import packages rather than including headers. But the import processing serial just means everything within the whole package of serial capabilities, read, write, everything else, we're just going to import all of it. It basically means the same thing as what you saw with the pound include in our Arduino IDE. And here we're setting up our serial port. It's a variable that we're calling myPort, and this is, keeping it aligned with the code that you would look at in the booklet. So I just named it myPort. Technically, on serial lines, you read from serial ports. So that's why they're calling it that. But anyways, we have our serial port. The next thing we have is we have our image, and this is the PNG that we're going to be reading in from. And this is what gives us our canvas that we'll look at later. And then we have a background color, which will change up. And then I've put in one additional variable, previous background color. And this is just to help if you're reading in or you're looking at some of the output and you're trying to read it, it's going to fly by pretty quick. So you can use a previous background color if you want to kind of slow some stuff down. I'm not going to really use it anywhere else, but I wanted to kind of bring it up, and I'll talk more about it in the draw function. But I wanted to kind of give you a springboard if you want to be able to make a little bit more sense of the output later on. But we'll look at that more later. With that all pretty much being in place, what we're going to do now is actually jump into our setup and get things started. And again, setup, just like in our Arduino IDE, setup is called when the application first starts up. So the first thing that we're going to see is we're going to see the size. And we see this 1, 1, right? Size 1, 1. And that basically means 1 pixel width, 1 pixel height. And what we are doing here is actually initializing a canvas, right? Processing IDE uses canvas to kind of draw on, if you will. And so this is setting up our canvas to be 1 pixel in width and 1 pixel in height. Now, the very next thing we're going to do is we're going to look at our surface, which is a built-in object that we have access to. And we're going to look at the surface, and we're going to say that the ability to resize it is true. And what that gives us is we recognize that 1 pixel width and 1 pixel height is going to be extremely small, and we're probably going to want more information on the surface of our canvas. So we're reserving the right to resize it later on. And that's all we're doing with the resize. Next, we're going to look at our color modes. And we've probably all heard of RGB, red, green, blue, right? And 255 is white, and 000 is black, and then everything in between is a mixture of red, green, and blue, right? So that's where we get our yellows, our oranges, and all other kind of colors. However, here we are changing that from RGB to HSB, which is hue, saturation, and brightness. And it's just another color scheme to get the specific colors we're looking at. And again, what we're doing here is going from 0 to 255. Again, I'm keeping with the book, but we know that we pretty much have from 0 to 254, right? We have 255 options. But again, I'm sticking with the book, and really what it is that 255 is telling us how many options we have, which is 255 options, which gives us from 0 to 254. But anyways, that's why we have the 255 in there. Next, we are going to actually load up our PNG that we're going to be looking at for a background. Now here you'll notice that I'm reading in from a local image rather than the URL that the booklet provided. That URL that the booklet provided did not download a Arduino image. Maybe you'll have more luck, but I'm reading directly from my disk. And you'll notice the ./, and the only reason for that is because I've stored the image in the same directory that I've stored my code base. So just make certain that if you stored your image somewhere else, you have either an absolute or relative path to the actual image, and the load image from the disk should be just fine. So the next thing that we're going to see when we talk about set size is we're going to use the width and the height of the logo, and we're going to set our surface area to that. Now, all that we're doing here is basically saying, the surface needs to really accommodate this image. Later on in the demo, you'll see that I drag it out so we can see the background color. But that's what this set size is doing, is just setting the surface area to match the dimensions of the image that we've read in. And this is why we have, or we previously called the set resizable to true, so that when we do read in the image, we can actually go ahead and set that size to the dimensions of our image. Here, the very next thing, and this is just within our Processing IDE, so we can read some of our variable information. So right now, this has nothing to do with serial or any of the print lines that we've seen in our Arduino or anything else. This is just an opportunity for this IDE to just kind of print out some stuff from informational components for us to understand what's happening in our program. But right now, these print lines have nothing to do with serial or reading from the Arduino board or anything else. It's just printing stuff out. Now in the book, they do this print line serial list. Serial.list, that function or that method actually returns an array. Well, the print line doesn't like the array. So this is not going to really show you the information that you're expecting to see. So for our code, we're going to remove that, and we are actually going to just iterate through the array for our port list, so we can actually see our available serial ports. And we'll see why this is important here in just a moment, because we're going to need to change another line of code that they have in the booklet, which is a little unfortunate, but it just is most likely going to need to be done. So when I run through this for loop here and I print out my available serial ports, I'm running on a Mac. So if you're running on a Windows box, or even if you're running on a Mac and you have a lot of serial devices plugged in, yours might look a little bit different, but make certain that when you run this, you have your Arduino board plugged in, so that way your Arduino board will show up in the serial list. So when I run that for loop, this is what I see. I see these 6 serial ports on my system. Now, when I'm looking at this, there are a few right off the bat that I know for a fact are not my Arduino board. Right? When I look at the Bluetooth incoming in the debug console, regardless if it's CU or TTY, I know that my Arduino board is not a Bluetooth, and I know that it's not a debug console. However, the USB modem 1101, that does start to sound awfully similar to what I would expect my Arduino board to be. However, I'm looking at this and I see a CU and a TTY. Well, I can tell you this, TTY is typically the serial port that you are going to be reading in from. So you'll notice on my 5 serial port, I have this dev TTY US modem 1101. Now the CU and the TTY, like I said, TTY is typically what you read in from. So it's likely that my Arduino board is either what I'm reading here at 2 or at 5. However, it is certainly, like I said, a little hiccup on the finger there, but those are the two that are most likely my my Arduino boards. However, what's important here is it absolutely is not what's at my index 0 of my available serial ports. It is absolutely not that. I can kind of test back and forth between the CU, USB modem 1101, and the TTY, US modem 1101. But absolutely, it's not going to be what this USB incoming at 0. And why that matters is because in the booklet, you'll notice this line of code where they do talk about, just by default, use the serial list at 0. Well, that's the Bluetooth, and it would not work. So we're not gonna use that. I put in, now I incidentally know that this is it. I experimented, and yes, this is my actual Arduino board. I put in the hard-coded string. You could, as opposed to the 0 that they have in the booklet, you could put 5 if it is yours. And hopefully that never changes. But again, you got to be a little bit careful with some of the code that they have in the booklet, because it does mess up a little sometimes. So anyways, this is what I've done to get my serial port. I verified it. It works. So a few things that needed to be changed. And now you see where I made some of the updates from the code in the book. And based off this, if you do a couple of experiments, you should be just fine as well. With all of that setup being taken care of, let's now move into the draw function, which is where we actually start reading from the serial line. Now, in this draw function, the first thing that we're going to do is we are going to say, is my port available? And a port that's not available, this returns an integer, this method, available method. If it's -1 or 0, it's not going to be available. So we're just saying, hey, if it's greater than 0, that means it's available. It could be 223, it could be 5, whatever. If it's a value above 0, we have our available port. And if you remember that my port, the way that we set that up was, this is what we were reading in, right? The TTY USB modem 1101. And again, you can see the 9600 here, right? When we were talking about making sure the baud rate aligns in the Processing IDE, which is in align with the Arduino IDE, that's where the 9600 needs to be identical on both IDEs. So anyways, we look at that and we make certain that our port is available. And if it is, we read in from our serial, and then we print out our background color. And the background color is what we're reading in from our serial line. And if you remember, in our Arduino, what we did to write to the serial line is we read in our analog input, 0 to 1023, divided by 4. So we have 0 to 254. And remember, our colors here in our Processing IDE have to be between 0 and 254, because that's what we set up our HSB as. So this is what we write to, and that's kind of in the center, just putting that segment of code up there as a reminder. And then we read in from the port. The next thing we're going to do is whatever color we've read in from the port, we're going to set that background color. And in this case, right, we're using our HSB, and we're saying whatever background color we have, that's going to go to the hue. And then we have our saturation and our brightness at maximum, right? And that's, if we set that down lower, it almost looks like the opacity's getting lower. So we have more of a transparent kind of background or darker background. So the 255 and 255 here, the hard-coded values, just means to make certain that the brightness more or less is at full at full capability. So you're always seeing the background color. And then finally, what we just need to do is make certain that the logo on our canvas is drawn at location 0, 0, which is really just the upper left-hand corner. So regardless if we stretch or expand the canvas, in your case, what you're looking at is the window frame. Regardless if we expand that or not, the logo, the image is still in the upper left-hand corner. Now, the only thing I want to point out here is this print line for the background color. You're gonna see it blazing by. Bum, 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 bum. If you wanted to, here is where you could use the previous background color. And if you could, you say, hey, if the previous background color is not equal to the current background color, then go ahead and print out. Otherwise, if they're the exact same, don't worry about it. Don't print out anything. And that, again, it's just an opportunity for you to be able to kind of slow down the print statements a little bit so you can make a little bit more sense out of them rather than just numbers flying by. But again, this is the Processing IDE from processing.org. We looked at it in the very early, downloading it in the very early videos of this program. So here's the pretty much first and only time we're going to use it. But that's all that there is to it. Again, this is reading in the serial port from our Arduino board, and based off our potentiometer's value, it's going to give us a particular color. So with that being said, the next video, we are going to look at the board, which is extremely straightforward. And then we'll also do a quick demo so you can see the actual processing application taking effect as well, with the coloration of the background changing as we turn our potentiometer. So with that being said, that was it for the code for both the Arduino as well as the processing, and we will see you in the next video for the board walkthrough and the demo. Take care, everybody.